Hello, future chemists. Welcome back to Neeraj Rishi Chemical Science. Today I'll show you the simplest and most effective method to balance chemical reactions using a step-by-step example. Whether you're a student just starting out or someone looking to brush up on your chemistry skills, this guide will make the process clear and straightforward. Let's get right into it. Balancing a chemical reaction is a fundamental skill in chemistry. It ensures that the number of atoms of each element is the same on both sides of the equation. This is crucial because it reflects the law of conservation of mass, which states that matter cannot be created or destroyed in a chemical reaction. Balancing a chemical reaction ensures that the number of atoms of each element is the same on both sides of the equation. Here's the method in 3 easy steps. Write down the unbalanced equation. Balance atoms one element at a time, starting with the most complex molecule. Adjust coefficients to balance atoms and ensure both sides have the same number of each type of atom. Let's break this down further. The first step is to write down the unbalanced equation. This is simply the chemical equation that shows the reactants and products without any coefficients to balance the atoms. For example, if we're looking at the reaction between hydrogen and oxygen to form water, we would write H2 plus O2 as H2O. Next, we balance the atoms one element at a time. Start with the most complex molecule, which is usually the one with the most atoms or the one that appears in the fewest compounds. In our example, we can start with hydrogen. There are 2 hydrogen atoms in H2 and 2 in H2O. To balance the hydrogen atoms, we place a coefficient of 2 in front of H2O, making the equation H2 plus O2 2H2O. Now let's move on to oxygen. There are 2 oxygen atoms in O2 and 2 in 2H2O. Since the oxygen atoms are already balanced, we don't need to make any further adjustments. The balanced equation is H2 plus O2 2H2O. Let's balance the reaction of hydrogen and oxygen forming water. H2 plus O2 forms H2O. Start with hydrogen. There are 2 H atoms in H2 and 2 in H2O. Balance by placing a coefficient of 2 in front of H2O. Now balance oxygen. There are 2 O atoms in O2 and 2 in 2H2O. The O atoms are already balanced. Check your work. 2H2 gives 4 H atoms, 2H2O has 4 H atoms, 1O2 gives 2 O atoms, 2H2O has 2 O atoms, both sides are balanced, and there you have it. The balanced equation is 2H2 plus O2 forms 2H2O. Balancing chemical reactions is all about practice and following these simple steps. If you found this helpful, like, share, and subscribe for more chemistry tips. See you next time. But before we wrap up, let's delve a bit deeper into why balancing chemical equations is so important. When a chemical reaction occurs, the atoms of the reactants rearrange to form new products. However, the total number of each type of atom must remain the same before and after the reaction. This is because atoms are neither created nor destroyed in a chemical reaction, a principle known as the law of conservation of mass. By balancing a chemical equation, we ensure that this law is upheld. Additionally, balancing chemical equations allows chemists to predict the quantities of reactants needed and products formed in a reaction. This is crucial in both laboratory and industrial settings, where precise measurements are necessary to ensure the desired outcome of a reaction. For example, in the pharmaceutical industry, accurately balanced equations are essential for producing the correct dosage of a medication. Now, let's consider a more complex example to further illustrate the process. Suppose we have the reaction of propane C3H8 with oxygen O2 to form carbon dioxide CO2 and water H2O. The unbalanced equation is C3H8 plus O2, CO2 plus H2O. First, we balance the carbon atoms. There are 3 carbon atoms in C3H8 and 1 in CO2. To balance the carbon atoms, we place a coefficient of 3 in front of CO2, making the equation C3H8 plus O2, 3CO2 plus H2O. Next, we balance the hydrogen atoms. There are 8 hydrogen atoms in C3H8 and 2 in H2O. To balance the hydrogen atoms, we place a coefficient of 4 in front of H2O, making the equation C3H8 plus O2, 3CO2 plus 4H2O. Finally, we balance the oxygen atoms. There are 2 oxygen atoms in O2, 6 in 3CO2, and 4 in 4H2O. To balance the oxygen atoms, we place a coefficient of 5 in front of O2, making the balanced equation C3H8 plus 5O2, 3CO2 plus 4H2O. As you can see, balancing chemical equations can become more complex with larger molecules and more reactants and products. However, the basic principles remain the same. Balance one element at a time, starting with the most complex molecule, and adjust coefficients to ensure the same number of each type of atom on both sides of the equation. Remember, practice makes perfect. The more you practice balancing chemical equations, the more intuitive it will become. Don't be discouraged if it seems challenging at first. With time and practice, you'll be able to balance even the most complex equations with ease. And there you have it. The balanced equation is 2H2 plus O2 forms 2H2O. Balancing chemical reactions is all about practice and following these simple steps. If you found this helpful, like, share and subscribe for more chemistry tips. See you next time. Thank you for joining us today on Neeraj Rishi Chemical Science. We hope this tutorial has made the process of balancing chemical equations clearer and more approachable. Stay curious, keep experimenting, and never stop learning. Until next time, happy balancing. If you enjoyed this video, don't forget to like, share, and subscribe to our channel for more chemistry tutorials and tips. Your support helps us create more content to help you succeed in your studies and career. See you in the next video.